to take Vassar stat, and I just entered some numbers in here. They were purely random, and I clicked calculate, and then it computed the n and sum of n squared, sum of the values squared rather, the sum of squares, and then the means. In this case, we see that if I was going to use a directional hypothesis, that group A would be less than group B. If I was not going to use a directional hypothesis, then I would just say that the mean of group A is different from the mean of group B. So this is the same results, and I just put it into the PowerPoint slide. And then finally, this notion of dependent versus independent types of t-test. An independent t-test is where you're comparing groups of people or different aircraft. So, for example, men versus women, minority versus non-minority, enlisted versus commissioned. Just independent groups of people. Aircraft type, is a jet engine or prop? Is it, 747 or 777? Just groups of things where you're going to be computing some mean. A dependent t-test is also referred to as a correlated t-test, and it's also referred to as a paired t-test. It's all the same. There is no difference in among those different terms. And a dependent t-test is where you have pairs of scores. Most commonly, it's pre-test scores and post-test scores for a single group of people. So you could have, for example, the first time that you took your licensing test compared to the second time that you took it. Hopefully that there would be a significant difference between those two. But again, you're going to have more than one person. All right. In summary, we covered very briefly this notion of statistical inference, and what I mean by that is that we are drawing a sample from a population, and we're using a random process in order to do that. When we draw that sample, we compute statistical outcomes, which are estimates of population parameters. In probability theory, we talked about statistical inference, and we talked about areas under the normal curve, and what constitutes typical scores and what constitutes rare events. And it was the p-values that were less than 0.05 that we determined were rare events. Therefore, they're statistically different from each other. And I went through the anatomy of a t-test as it's presented in Vassar stat. Take the same information in SPSS, and you will see virtually the same, not virtually, but exactly the same statistical outcomes, but they're going to be presented in slightly different ways, just in terms of how those tables are formatted. But the results are all the same. And over time, you're going to become very comfortable either using SPSS or Excel or Vassar stat or hand calculating. It doesn't matter. The statistical outcomes are going to be the same, and that's what you're most interested in. And then finally, we differentiated the independent and dependent t-test. Independent being groups of people, groups of aircraft, groups of things, as opposed to the dependent t-test, which has multiple scores, or I should say more than one score on a single group of people. such as pre-test, post-test, on a single group of people. So that is, at a high level, what is covered in the book. This week, your assignment was about computing the standard error of the mean, and this is going to come in very handy when we go into the work for next week, which is going to be analysis of variance. Yep. And we're going to cover the one-way analysis of variance, and I think factorial analysis. No, that's next week in Module 7. So here, the one-way ANOVA, just as a heads up, is just like the t-test. The only difference is that in a t-test, you're limited to 2 groups, whereas in a one-way ANOVA, you can have as many groups on one independent variable as you wish. Typically, you're not going to use more than 4 or 5 because you run into problems having enough of each of those conditions met with at least 10 or 20 participants in them. So I'll have an anatomy of a one-way ANOVA, and you can even use a one-way ANOVA when you only have 2 groups. It's going to give you the same outcome. The only difference is this is going to give you a t-score rather than in ANOVA you're going to get an F ratio, but t squared is F. So if you'd like to, just make up some data, run it in SPSS as a t-test, then run it in SPSS as a one-way ANOVA, look at the t value and the F ratio, square t, and see if it doesn't come out as equal to F. If you have any questions, you know how to get me. Have a good day.